Hello everyone and welcome to another Vulkan session. Today we're going to continue with the Vulkan tutorial and we are right now at the logical device and queue section. So let's get back into it. So let's start to run the current project that we have. It's built in properly and we are just printing the Vulkan extensions and layers that are available on the system. And we also last time added this physical devices section, so we are able to enumerate physical GPUs on the system. And for now we are just gonna use the first one that is enumerated, but in the future we're gonna score them and select the best one. And today let's see how are we going to create the logical device. So basically the type is PK device, so we can start by defining it. Can initialize it as move. Then we need to specify the queues and the physical device features that we are gonna use. And finally create a structure of the type DK device create info where we wrap all this information together. Okay, so let's start from the bottom up. Basically we need to call this function vk_createDevice. We're gonna pass the physical device, then pointer to vk_device create_info, which we are gonna fill in later. Then we're gonna pass null for the third parameter and get the device. You wrap this in the macro that we created to check Vulkan functions. So that's more or less what we need to do. But of course, if we try to run this, we are gonna get some errors. First, because physical device has another name, and secondly because this function cannot be found. So let me take a look at the Vulkan reference to snap the definition for this function. And go ahead and read to our binaries. So here after get physical device, vk_createDevice, it takes the physical device, the create_info, the allocation callbacks, which we don't use for now, and finally the output parameter vk_device. And we return as usual 98%. So something like this. Next we need to create this vk_device create_info, which looks like this. We copy it and add it towards the end. We can put it here after the extend. And then we just need to format this. So next by pointer, then plus we should be changing to We have the device create info. Copy. So the enable layer names is a pointer to a pointer of C characters. Then this can be 32. This is another and finally the enable features. We need to define these formats. We are missing the PK device queue create information. So we can wait here below. It's type. Next. Class. The family index. Then an array of queue priorities. So that should be all. Probably need to add also this PK device create flags. Hello Dinesh, how are you doing? Yeah, keyboard ASMR. Yeah, I really like the sound of this keyboard. Let's add this flags time. It should be create flags. And now we need to specify all of this and we call this function. So I'm trying to follow this Vulkan tutorial, which is very good, but it's done in C++, and so I'm converting it to Rust, which I'm trying to learn. So fields. Let's type. I am an MBA student. Can I learn coding? Is it very hard? I would say it's not very hard. It just takes time and dedication. But I would say everyone who is eager to learn can do it. Yeah. What is your MBA about? What are you studying? So the type should be okay, structure. Let's create info. Next is finance, marketing, human resources. That's very different from coding, no? But do you like to code on your free time, or would you like to learn? You don't like what you are studying? Well, I studied computer science, and while I was studying I also didn't like it. So yeah, but I think you have to stick with it and finish. On your free time you can do some other stuff that you like more and things like that. So we need to fill the queue create info count. We're gonna have just one. And then here we need to pass it's gonna be an empty array, but we're gonna fill it later. And then layers, I'm gonna say 0. And for the later on we can specify the layers. Let's set them as 0 and have it compile first. And the device features, where are these coming from? Okay, for now it's setting it as the default. So something like this. to add this enumeration value. So we can try to find it on the Vulkan header. So I can snap the value. And it's 3. So back to the page structure. I can add it here now. And I'm also gonna add the QCreate info, since we're also gonna need it. So there we go. You're back. Yeah, I was saying that even if you don't like what you're studying, that maybe you should stick with it, and then on your free time you can explore coding or programming. So now we should have this enumeration variant available. And we have here mismatch types, because we need to specify this as a pointer, like that. And then we need to make the device mutable. So now it compiles. Any suggestions on where should you start for beginners? It's hard to tell because there's a lot of resources, but do you have any programming language that you would like to learn in particular, or you just want to learn the basics? I don't know. I think that first you should decide what language do you want to learn. So what do you want to do programming? You need to have a goal, an objective. For example, me, I like graphics and game development, so for that you would probably learn C++ or C or Rust in my case. If you want to do web development, then probably you will learn JavaScript, HTML and CSS. It depends. Yeah, first you should look a little bit what you want to do and see which languages fit better. Okay, so now we should be getting a device. Let me see. If we get something here, or we just crash. Yeah, we got a cordon, so basically we need to fill now the QCreate infos, because we're telling it that we should have one, but we specified it as an empty array, so it's having troubles when accessing it. So let's read a little bit more. How do we create the queue-create info? So it's done via this type. So let's go ahead and create it. We'll do it again this type. The index is going to be null. Then the flags 0. Then we need the family index. This one I'm gonna hardcode to 0, but add a comment. And then the queue count is gonna be 1. And we also need the queue priorities. It should be a float array. So something like this. Does it work now? So yeah, now we were able to create the logical device, but we are getting a warning about validation. Yeah, basically it's complaining that we are not destroying the device, so that's right. Before we quit the application, we need to destroy the logical device. So first, probably it's gonna be explained next. Yeah, we need to do the proper cleanup using dk destroy device, passing the device, and folder. And we're gonna have to again define this function. So let's grab the signature. And add it to our definitions. So we're gonna put it after create device. Okay, extra device. It takes the device itself and the allocator. And doesn't return anything. So now this should compile, and if we run it, now we don't get the error that we were getting. Okay, cool. So I think we don't need this block anymore. I'll put here a comment. That's a lot of code already just for initializing Vulkan. But we're gonna clean it up later so it will look nicer. For now I don't want to abstract too many functions because I want to have the code all in one place so it's easier to understand. Okay, so now that we have a device, we can retrieve the queue handles. And this is done via this get device queue. Okay. So we call it by passing the device, the graphics family index, which we are hard coding to 0 for now. Then this third parameter, I don't know what it is. So let me check in the reference. This is the queue index. Okay, so since we created only one queue, we can pass in 0. And then we can store the results in a graphics queue object. So we create first. Something like this. And this function also doesn't return an error. Let's put this function in here. Copy the parameters. And now it should compile. Let's double check that we get something other than 0. And we get some handle. So basically that was this chapter. I'm gonna clean it up a little bit by hardcoding the queue family index. So we hardcode it for now, but I will do this later. Then also here. double check that this still works. Let's see the changes. Okay, so commit this. And push this to the remote. So let's continue reading through to the next chapter. Since Vulkan is a platform agnostic API, it cannot interface directly with the Windows system on its own. We need to establish the connection using the Windows System Integration extension. Put the scores, the first one, which is BKKHR surface. It exposes a BK surface object that represents an abstract type of surface to present rendered image. Okay. This is an instance extension. And should be already included because it's returned by glfl.w, but we're not using glfl.w, so let's actually double check. Okay, we already specified that we want this extension, so we got that part. Now we need to start by creating a surface. And here it is explaining how to do it for Windows Win32, but we are gonna need to do it for X11. Yeah, the process is similar for other platforms like Linux. PK create XCV surface takes an XCV connection and a Windows as creation details. So let's see. We do this. We do it before picking the physical device. Okay. So in here. And then we destroy it before destroying the instance. Okay, so let's try to do it. This one is going to be middle. Here it's using the BK Win32, but there should be one for X11, I think. See if we can find it. Maybe X11. Oh man, this PDF search is ultra slow. I hate it. I hate it. What? Okay. This is the function that we need. So we can check the result of it. And then just call it with the instance. We're gonna need this VK surface creation info, which we can put in here, and then we pass in the allocator plus null, and we get back the surface. So let's add this to the Vulkan definitions. I'm gonna put a comment to say that this is an extension. And we can tell some results. So we're gonna need to declare a few things. Do we have a surface? No, we don't have a surface. And I think it's just a handle, right? Okay, surface. Okay, chat. Yeah. So we can add it to okay. Fine. Here. We have this macro for defining Vulkan handles. We just create an anonymous struct. So we can copy some of these. And put it in here. That's one thing. Shipping, KHL. Still complaining? No. And then we need the actual create information struct. We can also search on it here. It's gonna be easier. Why is it not finding it? Ah, it's going to be in another file, I think. Anyway, let's take it from here. in here. This track is only going to work on Linux, but that's okay for now. It has the path stand. The VNs. Some flags. Which we're gonna need to define, and then the display, and the window. And these are actually two types from X11. Do I have them? I have them. Because I'm using them here. I'm opening a display. Oops. Hello, Paco. Te deleite. So I have this module for X11, and I think that here I have the display type. So maybe I can import those types from the Vulkan header. Can I use anything like this? Okay. Yeah, that seems to be working. Now I just need to define the flags. Put them up here. And see the flags and files. Okay, now we just need to fill in this structure properly. So for this type, we're gonna have to use this constant. Then next is another name. Then we only have the flags, which I will specify as 0. Yeah, and they must be 0. And then for the display and the window, we're gonna just have to create a window, I guess. I'm gonna have to move the code for creation of the display and window above. So this was the code that we were using for creating the display and also for the window. So I'm gonna grab this and put it at the top. Like this. And see if we don't get any more. We're still getting. Close the limiter. What am I missing? Let's try to compile. Right, I'm missing a parenthesis here. And now I'm missing this define. Alright. So let me actually try to find it. Let's grab for it. Import Vulkan. Well, this one is in Vulkan core. And it's defined as this number. So can put it here. This is 4000, so it comes before this one. And here we're probably missing still some types. And we are missing something still. So it takes the instance, the creation info, the allocator, and the surface. And probably, what are we passing in? The instance, the creation info, the allocator, and we forgot to pass in the surface. But now it should work out. And it does. And we can print it. And see if we get anything other than 0. We get something back, not 0. But now we're getting. Yeah, probably we need to clean up also the surface. Probably at the end. Yeah. So here in the tutorial, we need to call destroy surface right before destroying the instance. So passing the instance, the surface, and a new pointer, and that should be it. Just we need to add in this function. Check that it doesn't return anything. So if I run it now, am I gonna get any error? No? Okay. So we managed to create the surface as well. Let's commit the progress. So, querying for presentation support. Although the Vulkan implementation may support Windows system integration, that does not mean that every device in the system supports it. Therefore, we need to extend is device suitable to ensure that the device can present images to the surface we created. Since the presentation is a queue-specific feature, the problem is actually about finding a queue family that supports presenting to the surface we created. It's actually possible that the queue families supporting drawing commands and the ones supporting presentation do not overlap. Therefore, we have to take into account that there could be a distinct presentation queue by defining queue family structure. Okay, so it's possible that the queue for graphics and the queue for presentation are not the same. So far we are hard coding the queue family, right? To be the first one of the first device. But when we choose a device, we can actually query if it supports presentation to the surface or not. So I'm gonna add this code here where we are querying the physical devices and getting the queues and so on. I'm gonna add this code there. Even if we still hardcode the queue index, just to follow closely with the tutorial. So I think here device should be device, get physical device support. Let me grab definition for this function. And we want it to our list. It takes in the physical device, then the queue family index, the surface, and it returns a boolean pointer to indicate whether it is supported or not. And also a result, because this might fail. So we can call this for every queue family index. So here in main, can actually do this for every queue. Something like this. Now that we're using the index, we can get rid of the underscore. And we're getting some errors. We don't want to show it. Found U32, expected U32, found U32. The type was U32, right? So, we just cast it. And actually, let's copy this. And let's call it with the actual physical device that we select. The one that we are hard coding, and so basically I want to know if the graphics family index that I'm using, hard coded, does it support presentation as well, and if it does, I will continue like this. Otherwise, maybe I need to improve the selection of the device and queue. And indeed it does. So we can use this queue without worrying too much. Okay, now creating the presentation queue. The one thing that remains is modifying the logical device creation procedure to create the presentation queue and retrieve the queue handle. Right. I don't think we need to worry too much about this because we already saw that the same queue family supports graphics and presentation. So it's fine to only retrieve one queue. Maybe I should add a comment here. just so I don't forget, I will have this comment in here. And then it gets the queue, but we don't need to do that. Okay, before starting with the swap chain, I'm gonna take a small break. So I'll see you afterwards.